The independent sample t-test is designed to compare the averages of two groups to determine whether or not the differences are statistically significant. In this example, we compare the white blood cell counts of males and females. The white blood cell count data was obtained from the National Health and Nutrition Examination Survey. The first step is to set up the hypotheses. The null hypothesis is that the means are equal, and that there's no difference in the white blood cell counts of males and females. The alternative hypothesis is that the two means are not equal, and that there is a difference in the white blood cell counts of males and females. The second step is to compute the test statistic. The test statistic has the form: the first sample mean minus the second sample mean divided by the square root of the first standard deviation squared divided by the first sample size plus the second standard deviation squared divided by the second sample size. In order to compute the test statistic, we must determine the sample sizes, sample means, and sample standard deviations. To do this, we're going to open the white blood cell count dataset in StatCrunch, and then we're going to go to Stat, Summary Stats, Columns. Select the males, hold down the Control button to also select the females, and then select the statistics we want to compute, the sample size, the sample mean, and the sample standard deviation. Again, hold down the Control button, or else just press the Compute button and compute all of the statistics. So now we can substitute these values in. In the numerator, we have the first sample mean, 6.78695, minus the second sample mean, 7.44259. And then in the denominator, we have the square root of the first standard deviation, which is 1.97093, squared divided by the first sample size, which is 23, plus the second sample standard deviation of 2.89172, squared divided by the second sample size of 27. We need to evaluate this on the calculator, and then we obtain negative 0.94771. The test statistic in this example is close to -1, meaning that the white blood cell counts of males is about 1 standard deviation less than the white blood cell count of females. This is not a very substantial difference. The third step is to compute the p-value. The test statistic has a distribution that can be approximated using a student t-distribution with 22 degrees of freedom. The degrees of freedom are obtained by subtracting 1 from each of the sample sizes and then choosing the smaller number. In this case, the sample sizes are 23 and 27. Subtracting 1 from each of these sample sizes results in 22 and 26. Choosing the smaller number leads to 22 degrees of freedom. We can now sketch the student t-distribution, which is a distribution which is centered at 0. We can shade in the area to the left of the test statistic, negative 0.94771. Since the alternative hypothesis is of the not equals form, we must also shade in the area to the right of positive 0.94771. The p-value is now computed as the area of the tails. To compute the area of the left tail, open up the student t-distribution calculator in StatCrunch. Under Stat, Calculators, T. Enter the degrees of freedom as 22. Enter the value of the test statistic, negative 0.94771, and press Compute. And we end up with an area of the left tail being 0.17678. Now, since the right tail has exactly the same area, we can find the p-value by doubling this value. Our fourth step is to interpret the results of the test. The p-value of 0.356 is much larger than 0.05 and is considered to be no evidence against the null hypothesis. The difference in the white blood cell counts of males and females is not statistically significant. I'm not a medical doctor, but the differences in the white blood cell counts seem to be of little clinical significance.